Hi guys. Today we're going to be focusing on the sine wave and then the cosine wave and how to transform those particular graphs. So we're going to talk about the parent graph and where it starts and why that works out the way that it does. If you guys recall from geometry or from an earlier class hopefully, sine is found by opposite over hypotenuse. So if you remember the SOHCAHTOA stuff, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if we look at this triangle here, we have our central angle. So this is our angle right here. And in reference to this angle, this side right here is the adjacent. That happens to be our x value. This side is our hypotenuse. That is our radius, and that radius is 1 on the unit circle. And the opposite side is our y value, because that's how much you go, x values over, y values up, so on and so forth. So the sine is found by this opposite side over the hypotenuse. And since the hypotenuse is 1, then our y value is just the sine of that particular angle. So if we start from the very beginning, when we go around a unit circle, we always start here at 1, 0. So as I go around the circle, this part over here is recording what's happening to my altitude, so how far I'm going up. From 0 to 180 degrees, or 0 to 1 pi, I have positive altitudes because I am above 0 on the y-axis. X-axis, just kidding, right here. So I'm above the x-axis, so my y values are positive. That's a better way to say it. As I continue from pi to 2 pi, or 180 to 360, my altitudes are negative, so my y values are negative, and I go around full circle. So when you actually graph a sine wave, there's an expectation that you have 5 specific points. These points are going to be the starting point, which on the parent graph is at 0, 0. When you start transforming it, it needs to be at your midline. So the midline is, for this one, our x-axis. As we move that around, I'll show you what happens with that in just a few minutes. But we start at our midline, go up 1, or go up what our altitude is. That's going to start to change in our transformations. Go back down to our midline at pi, down to -1 at 3 pi over 2, and then back to 2 pi. That is one full cycle. So the period length here is 2 pi. The cycle and those 5 points, so our 0, 0, so our midline up, midline down, and midline is what we need to put in there, as well as specifying our midline. So if I go to just a basic graph, and I put in sine of x, and I have changed my scale to be pi over 2. If you're using Desmos, you can do that right here. Just type in pi over 2. I'm also going to zoom in just a tad. So right now, my midline is at y equals 0. So that green line right there. No, sorry. Anyway, if I change my my k value. So think back to parent graph transformations when I had an a, which changed the stretch factor, an h, which moved my graph left or right, and a k, which moved my graph up or down. We're doing that same thing here. So if I put, here's my starting point at 0, 0. If I put a new one in that is sine, not x, sine, parentheses x minus pi over 2, what that did was it moved this starting point for my original, the original is in blue, over to pi over 2. So it moved my whole graph from here to here. If I move that, so I'm going to change that one. If I move it, if I just want to move the whole thing up, if I do +3, and I'll move this down, Then I took my midline that used to be at y equals 0. Now my midline, if you can tell, is at y equals 3. And specifically, the k that moved our vertex and whatever else when we were dealing with parent graph transformations, that moved it up and down, the k is specifically your midline. So it's important to draw that in anytime you have that transformation. It makes the whole thing easier to do, because with that sine graph, remember, you start at your midline, go up 1, back to your midline, down 1, and back to your midline. So if you know that process, that makes that transformation of up or down a little easier to do. So when I have multiple ones, so I'm back to my regular sine graph, I also have an altitude transformation that's changing the a. So if I change my a value, so in front, to 3, as you can tell, now instead of going up to 1, where I was before with my regular sine graph, I'm now going up to 3, back to my midline, down to 3 pi over 2, or down to negative 3, and back to my midline. So the midline, again, doesn't change unless you have a plus or minus k at the end of your graph. But your altitude is always going to be how far you are up and down from your midline. So the midline is really important to draw in. That makes the whole thing easier to do. The last transformation I want to talk about, and this is the one that's most tricky for people, is b. And this we didn't do in our parent graph transformation. B, so let me see if I can type this up here. We'll see. So a sine b x minus h plus k. So it's not going to be able to graph anything there, but I want to show you what that transformation, or the general form of that equation, is. The k that's hanging out there by itself, that's what's going to change your midline. The h moves it left or right, but remember, because this is x minus h, it always moves it the opposite direction of what you think it's going to move it. So if it's x minus pi over 2, the starting point goes from 0, 0 to pi over 2, 0, and it's going to start here instead. So it moves it, if it's x minus something, it moves it to the right. If it's x plus something, it moves it to the left, because it created a double negative. A is your altitude. That one's easy enough to remember. So that's how much above or below your midline you're going. And then B is new. B changes it's a horizontal stretch or compression. So what B actually does is changes how many cycles are completed within 2 pi, and it's always within 2 pi. So if I look at my regular sine graph, I'll take the 2x off. My regular sine graph completes 1 cycle between 0 and 2 pi. If I change this to, I'll do that just there, it was too confusing earlier. Change that to 2 pi, or 2x, I'm sorry. I start at 0, midline, down, midline, and this is 1 cycle. But now my period length is only pi. My frequency, is specifically what B is called, tells me how many cycles I complete within 2 pi. So here I've completed 1, and then I go back up, midline, down, midline, so I finish 2 complete cycles within 2 pi. So if I start making multiple transformations, so sine x minus pi, I need my thing there, and then close my parentheses, plus 1. I changed my midline to 1, and I also changed my starting point to pi. So really, I'll cut that off right there at the edge. My new starting point was at pi, going up 1 from my midline, back to my midline, down to my minimum, back to my midline. So there's my 1 cycle. Sorry, mouse got stuck. There's my 1 cycle. If I just change sine 3x plus 2, I have changed both my period length as well as, so my frequency is now 3, as well as moved that up to a midline of 2. So what I would want to draw, if I were graphing this myself, I would draw that midline at y equals 2, and then I'd build it around it. I'd put my starting point at 0, and then I'd put my ending point at 2 pi. Now, because of that frequency, I know I have to finish 1, that's 1 cycle, 2, that's 2 cycles, and 3 cycles between 0 and 2 pi. When you start getting into further transformations, you have to be really careful. My biggest piece of advice is to build your graph around your midline. Always put that midline in first, and then determine your starting point. I'm going to make a separate video for the cosine graph because this one is already at 11 minutes. So that is your sine graph. Hopefully that is helpful to you. And if you see the next one for the cosine graph, hopefully that helps you as well.